Hello, everyone. My name is Kevin Tarr. I am an iOS engineer, and today is day 17 of Algorithms in Swift. So, today we're going to be doing a problem where we're going to be analyzing a string and detecting whether it only has characters that are numbers. Numbers meaning digits from 0 to 9, like this right here, okay? So, any other character that a string may have, like this, or like this, or like this, would be a false statement returned from the function. Okay, we only want true numbers, and if you're thinking this problem is pretty simple and straightforward, I think this would be a reverse mirage problem for you because this problem actually, if you want to solve this in an efficient way, um, this problem is a bit trickier than you may believe it to be. So let's begin. So our problem states, write a function that accepts a string and returns true if it contains only numbers, i.e. the digits 0 through 9. We have some sample test cases here. The input 0, 1, 0, 1, 0, 1, 0, 1 should return true because they're only numbers. The input 1, 2, 3, 4, 5, 6, 7, 8, 9 should return true. The input 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,808 should return true. Hint, hint, if you watch other previous videos, hint, hint, the input 1.01 should return false because the decimal prevents it from being a true number string with just only numbers and not other characters. And the input 1 million should return false because a comma is not a number. Okay? So the reason why I said that people may be underestimating this problem is because if you were to try to approach this in a very straightforward way, um, like true number, um, passing a string, return a boolean, and you try to convert the integer into a string and ask if it's equal to nil. If it's not equal to nil, return true. If it is equal to nil, return false. And then you would stuff this big 9 quintillion number in. What do you know? False. But the interesting thing about this is if you were to lower this down by 1 and change this to 9 quintillion with a 7 at the end, it'll return true. Why is that? Because integers, as I've said before, hold a range of 0 or negative 9 quintillion to positive 9 quintillion. This is the maximum height that a number can be at. Okay, so anything past this, an integer cannot hold. An integer only has a range of 9 quintillion, like below, to negative 9 quintillion to positive 9 quintillion. Okay, so anything higher than that is going to fail because the integer is going to recognize it as a nil number because the integer only has numbers within that range. Okay, now you could be even, you can't say, okay, you know what, I understand other integer types. Let me actually convert this to an unsigned integer, which will take me to 18 quintillion, and that will solve my problem, right? Wrong, because if you were to do do that, even if you go one past that, you still are presented with the same problem. 18 quintillion, adding 1 to it. Let's see. So we can do that problem right now. We could print out 9 quintillion plus itself because unsigned integer is double that. Um, uh, convert it to an unsigned integer. And have it print itself. And we have unsigned integer's maximum value, okay? So if we were to add 1 to this effect, let's make this 19 quintillion rather than 18 quintillion. We're doing something like adding 1 to this to the quintillion stack. It would result in false, even though this is a number. There's no commas, no periods, no extra characters, but unsigned integer only goes up to 18 quintillion. So if going up higher than that, automatically Swift recognizes as nil. So this approach, while in theory it sounds good. It's a rather facile approach to solving this problem. So I'm going to show you two valid solutions to solving this problem. Okay. So instead of returning an unsigned int, we could do the brute force approach where we go through each letter in the string and ask if int string I is equal to nil, return false. And then we just return true at the end. So basically, we're just going to go over each letter in the character, each character in the string, and ask if it can be converted into an integer. It could be converted to a character, or it could be converted to a string and then to an integer. And if it could be converted into an integer, continue on. The moment you find a character that cannot be converted to an integer, return false. Okay? Immediately exit the function. If we go through all the characters in the string, and every character can be converted to an integer, we know that we only have numbers in it, return true at the end. Okay? And this is order and complexity, because in worst case scenario, you have to go through the entire string. But see, now we have true here. We have, we have 19 quintillion, a number this large, returning true. And we can even double it and make it even bigger. We can make it even something like this size, and we'll see that this returns true. But if I add like a period at the end of this, this will return false because I found a period. Okay. So it only evaluates true numbers, So that's a brute force approach, and this is perfectly valid. So if you were to show this an interview, this would be a perfectly valid approach to solving this problem, okay? But I want to show you guys a even more efficient and impressive way to solve this problem that is, I believe you can do this in one line of code, and this is a bit smug and a bit show-offy, but I think that this is a great use case for what I'm about to teach you guys, and I think that this is a very valid solution. So what you could do is stuff everything into a set, okay? So you could return the string, you get the string, you can get a count of the string, that's passed in, and then you convert the string into a set. Oh, no, not even a set, sorry. Let's not do sets, that's a whole different solution. That might be more complex. Let's convert it to a string, okay? Well, let's keep the string, and let's actually use a filter. And we'll only analyze characters that are either greater than 0 or equal to 0, or less than or equal to 9. Okay? And we'll ask if the count of the string, the original count of the string, is equal to the filtered count of the string once we eliminate any characters that are not between 0 to 9. If the count is equal, if the count of the original string is equal to the filtered string, we know that we have a string that only has numbers inside of it. If it differs by any number, any point, that means that we don't have a complete string of numbers and that we should return false, okay? So by doing it this way, return true. And if you were to add a period here or a comma at the end, return false. Cool. So this solution works. Let me know what you guys think of the solution in the comments below. Hopefully this problem helps you and the solution helps you. And if you have any other proposed solutions, please be sure to share a comment on the post below. I'm Kevin Tarr. Thank you guys for watching. Have a good night. Bye.